Hello, good morning, guys. Welcome back to another science session. Today is Monday, April 27, 2020. Our lesson for today is titled Energy Transfer Through Matter. And our teaching point is I can explore how energy moves in the process of conduction and explain its different stages. So that means that today we're going to keep on talking about thermal energy and the different ways this one can be transferred, right? So I recommend that you pause the video now and get to copy the date, lesson name, and teaching point in your notebook just before we continue with the question of the day. In our question of the day, we have, what is the energy transfer type in moving gases or liquids? So we have radiation, convection, conduction, and thermal energy. I recommend that you pause the video now and get to give it a try. When you're done, click on play and let's take a look at the answer. And the answer is convection. All right. So convection is the transfer of energy in moving gases or liquid. So that means that when you have heat, gases, or liquid involved, then probably, actually, you are in a case of convection, such as the warm air rising above a heater. In this case, if we take a look at the image on the right, we have a pot on the stove, right? Now, convection is caused by cool parts sinking and pushing warmer parts up into the liquid or gas. As the warm and cool parts move, they cause rotating currents, as we can see right here. The currents spread thermal energy throughout the material. However, if we take a look at this one, we have a bigger system right here, which is the whole planet actually. In the tropics, near the equator, warm air rises, right? When it gets about 10 to 15 kilometers above the Earth's surface, it starts to flow away from the equator and towards the poles, as you can see right here. Air that rolls just north of the equator flows north. Air that rolls just south of the equator flows south. When the air cools, it drops back to the ground, flows back towards the equator, and warms again. Okay? Then now, warm air rises again, and the pattern repeats. This pattern is also known as convection. Happens on a global scale as well, as we can see right here. And it also happens on a small scale within individual storms. That is a phenomenon that we're going to watch in depth later on. Now, but because Earth is spinning, the air that moves north and south from the equator also turns with the spin of the Earth. Okay? So, air going north turns to the right, and air traveling south turns to the left. The power of Earth's spin to turn flowing air is known as the Coriolis effect. And that's something really cool that we're watching on our next module. So let's continue with our lesson for today. We continue working on our module energy transfer lesson 4 titled as heat. We're trying to answer the essential question, what is heat? So going back to our teaching point, I can explore how energy moves in the process of conduction and explain its different stages. But I can actually read in our lesson name, energy transfer through matter, right? We already know about energy transfer when it's get one body or system passing some energy into another one, right? But what is actually matter? So let's take a look. In science, matter is the term for any type of material. So basically everything is matter. Matter is anything that has mass and takes up space. Even air can be considered as matter, even though we cannot see it, it actually has weight and occupies a space. It is to say that it has a volume. So atoms and compounds are all made of very small parts of matter. Those atoms go on to build the things you see and touch every day. Matter is defined as anything that has matter and occupies a space. It actually has a volume. So right here we have different examples. So we have, let's say, some ice cube, water right here, volcano, some gold bars right here, a piece of rock, wind, everything that we know is actually and can be considered as matter. We probably have seen the different states of matter, probably the three more basic ones, which are solid, liquid, and gas. There's another one that we have probably seen, which is plasma, but we're not getting into that in this video. Right. So today we're going to be taking a look at the simulator. We had the opportunity to actually try sound waves and light, seeing them in action, but today we're going to take the chance to actually see how heat behaves in this simulator. So we're going to be taking a look at how energy moves in the process of conduction. We must remember that for conduction to happen, the two objects need to be touching, the warm one and the cooler one, right? So basically we're going, these small balls right here represent the molecules, the molecules of the solid of the object, let's say a frying pan. Right here we're going to have the temperature, and right here we're going to control the flame, how much fire we will have, and right here we can activate these red bulbs right here so we can actually see the energy transfer going on. It is to say the kinetic energy in motion. So now let's open our books on page 72 where we have our inquiry activity. We're going to begin. No, we're not going to begin with that. But let's write this now. So right there we have three basic steps that we need to follow in order for us to carry out our investigation. So we're going to use the slider to set the flame height to low. So we're going to basically turn the stove off. Then we're going to shade the buttons to show the kinetic energy of the particles in red so that actually we can see how this energy is being transferred. And then we're going to observe the particles. And we're going to record those observations in that table that we have on page 73. Right? So right there we have three tabs. One for when the flame height is low, then when the flame height is medium, and then when the flame height is high. So basically we're going to be paying attention at the behavior we have, or the particles actually have, in those three different scenarios. Then in our second case, we're going to use the slider to set the flame height to medium, and then we're going to record your observations. At last, you're going to use the slider to set the flame height to high, and then you're going to record your observations as well. All right, so let's take a look now at our simulator. All right, guys. So in our previous sessions, we had the opportunity to take a look at how sound waves behave and also light behave. So today we're going to take a look at this energy transfer situation, more specifically conduction. Right, so let's consider the following question when we analyze the following simulation. So how does energy move through a solid when it's heated? Use the motor to heat and cool a metal pan and watch what happens to the atoms in the metal. How does the energy get from the bottom to the top? So let's start. Zoom in, zoom in, zooming in. We're inside the frying pan. There you are. Now, since this is the solid, you can see that the atoms or the molecules that compound this object are really attached to each other. So the closer these molecules are, then that means that the hotter that object is. Okay? Now, so we're supposed to check on this one to actually see the movement or the energy of our molecules in the process. So as you can see, as I check on this box right here, I can see some movement right there. Now we're supposed to begin with our flame all the way down to off. As we turn it off, you can see that the temperature is decreasing right here, but also the red balls that we had before are turning off. So that means that the thermal energy that this body possesses is going down as well. And therefore, if the thermal energy of the system is going down, that means that the kinetic energy of the molecules is going to be down as well. As you can see, this is off right here, so pretty cool right here. So in our first step, and pay attention because we're going to be taking a look at what is going on so you can actually write your observation on the chart. So we're going to set our flame height to low so you can see what happens. So let's say that this is low. I can see that the lower, or the part that is closer to the flame is actually way more active than those at the top, which are further. But we can see that some energy transfer is going from the bottom all the way up. And as you can see, we reach the maximum temperature that this flame height provides. So we have some of movement, some energy transfer, but not that much. So yet again, take a look at what's going on right here so you can write your observations on the table. Now, in our second step, we're supposed to get the flame height all the way to the half. So right here, let's take a look at what happens. So I can see more activity. That means that the kinetic energy of the molecule is increased because I see a lot of movement right here. And I see that more energy is being transferred from the bottom, which is the side of the frying pan that is way closer to the heat, all the way to the top of the frying pan. Remember that this energy transfers equally spread out in the frying pan as it is produced by the heat. So yet again, take a look at the temperature right here. We reach the maximum for this flame height, about 200 degrees, actually Celsius degrees. So yet again, take a look at the scenes that we have right here so you can write your observations in the box that says flame height medium. I can see some movement, some more movement actually, in the molecules way at the bottom of the system, right? Something that we didn't notice in our past try. At last, we're going to use the slider to set the flame height to high, and then you're going to record your observations. I'm going to turn this off so we can actually appreciate what it's going to be like when we slide this all the way to high. As you can see, the temperature is way higher this time. Wow, about 350 something Celsius degrees. So right here, if we click on this box, we're going to see the kinetic energy going up. So right here, our frying pan is ready to cook some rice. It's really hot. We can see more movement in the molecules. That means that the kinetic energy of the system is way more higher, gradually higher, than the one that we had in the previous attempts. Obviously, because the thermal energy is increased. We said before that thermal energy is that inner energy that a body possesses. Since the flame is actually transferring some energy in this form of heat to this frying pan, the molecules inside this frying pan are more active than when we have our flame set to medium or low, let's say. So yet again, I see even more activity at the top of the system, actually the frying pan. So that means that the metal pan is already way hot in every part of its surface. So yet again, take a look at the activity, or actually at the scene that is going on right here. So you can actually compare with the previous two attempts and come up with your new observations. So we're going to stop our simulation right here. Let's give it another try because this one is actually too cool. As we can see, we turn our stuff off, then the temperature drop down to zero. We can see that the molecules are way quiet. Let's take it all the way half. We got some pretty much movement right here. When we take it high, they move a lot. So now let's try again with the color atoms on. It's off right here, so our molecules are cooling down when we don't have that much kinetic energy. Let's slide. They go crazy right here. Even crazier on this one. And then at last high, they get to their maximum expression. So we're going to stop our simulation right here. I hope that you have taken a look at what happened in every stage, so you can actually write your observations and come up with a conclusion. Alright guys, that will do it for today. I hope that you have enjoyed this lesson. I'm really eager to actually get to read the conclusion that you got to. So don't forget to upload your work to CISO. See you next time. Bye bye.